Alright, welcome back. Intro to Engineering. We are now in Unit 5, and this is Activity 5.1, calculating properties and shapes, properties of shapes, my bad. This is going to be completely done in Canvas, alright, so you do not need to get into my PLTW for this assignment. From the home page, you'll go to course content, and then Unit 5. Underneath Unit 5, it is Activity 5.1, calculating properties, shapes. This here is the assignment, okay? We're going to go over this, and this assignment will be graded, all right? So make sure you're paying attention, taking good notes. I will let the sub determine whether they're going to let you work in groups or not. That's going to be up to them. And make sure that you get this done. It will be the whole assignment, all right? So let's get started. Underneath the presentation tab will be a PowerPoint. And here is the PowerPoint. I'm going to go into that. So to start, there we go. We need to talk about what is a shape, what is a solid, things like that. So to start, a shape describes the two-dimensional contour that characterizes an object or area. And that would be anything like squares, triangles, ellipses, all right? The keyword here being two-dimensional. So for example, circle, ellipse, triangle, square, rectangle, all right? This would not be a shape, right? Because it is a 3D object, okay? Area is the extent or measurement of a surface. And the most generic version of this is how much area is in here. Alright, and on your formula sheets, you guys will have access to this on the test, as well as it's available to you pretty much through the entire internet right now for your assignment. So let's talk about a very generic way to think of this. To calculate the area of a square, if this is my square, I'm just drawing that right there. If that is my square, and each block represents 1 inch, that would mean that from here to there is 2 inches, and from here to here is 2 inches. And the formula to find the area of a square is, if it's a square, it'd be side squared, but base times height for squares and rectangles. So base times height equals area. And this would be 2 times 2 equals area, and it'd be 2 inches times 2 inches, meaning you have 4 inches squared. Right? You need to make sure you include that. 4 inches is not an area measurement. 4 inches is a length measurement. So 4 inches squared it would be enough to give information on an area. Okay. So that's our area. A circle, that is a round plane, opposite from a square, which is square, right? And then is a round plane whose boundary consists of points equidistant from the center. So equidistant meaning every side is the equal amount of distance from the center point. So it's 2 inches from here to the center, it's 2 inches from there to the center, 2 inches from there, there. All right. So that's what equidistant means. The circle is the simplest and strongest of all the shapes. The circles are found within geometry of countless engineered products, buttons, tubes, wires, cups, pins, all right, all those things. And then a drilled hole is also based on a simple circle. In order to calculate the area of a circle, it's the concept of pi that we must be understood, and that is pi is a constant, and that's the symbol. Some of this should be reviewed for most of you. It is a constant ratio that exists between the circumference of the circle and its diameter. So the ratio states that for every unit of diameter distance, the distance around the circle will be approximately 3.14 units. So pi is always going to be 3.14. There are infinite digits to pi, but we're not going to worry about that. We'll leave that for future math classes and things like that. For the purpose of this, if you type in your pi button on your calculator, or you literally type in 3.14, we'll be close enough for the purposes of this assignment. So to calculate the area of a circle, it's the radius we need to know. or the diameter, because we could figure out the radius from there. So area is pi r squared, and pi is 3.14. So whatever our radius is, so let's do a very simple one. Let's say the radius is 1 inch. 1 times 1 is 1. 1 times 3.14 is 3.14. So if you have a radius of 1, then the area is 3.14. An ellipse is generated by a point moving in a plane, and we're going to get into that in just a second. I just wanted to run through another project or example down here. So if we have a circle, and the radius of that circle is 4 inches, let's go ahead and do that. So area equals pi r squared. So I'm going to give you guys a minute to do that, and go ahead and write that down, see what you get, and we'll do that here in just a second. Calculator. Alright, so to figure this out, we know the radius is 4. So 4 squared is 16. And then 16 times 3.14, or pi, okay, is there, 50.24. So 4 squared equals 16. So now you have pi times 16. And that's pi times 16 ends up being an area of 50.24 inches squared. Okay. And that formula works every time with circles. Okay. So let's talk about an ellipse. An ellipse is generated by a point moving in a plane, so the sum of its distances from two other points is consistent, alright? Meaning from here to the focus and here to the focus is the same, and vice versa. So let's talk about how to calculate your major axis and your minor axis to be able to get the area of an ellipse. So your minor axis is 2 times b. So think of this as your radius. You have radius A and you have radius B for your ellipse. Okay, this would be 2A from one side to the other. 2B is from top to bottom. So once again, 2A is left to right. 2B is top to bottom. That's just for the example of this ellipse. Your major axis is going to be the greater distance of the two. So if this ellipse was flipped vertical, your major axis would now be up and down. To calculate the area of an ellipse, the lengths of the major and minor axis must be known. All right, here's your formula. Area equals pi times A times B. And these formulas are on your formula sheet as well. Okay. So let's say the major axis is 4 inches, and let's say the minor axis is 2 inches. All right. So I have area. So the major equals 4, minor equals 2. All right, and my formula is area equals pi times A times B. All right, so remember this is 2A and 2B over here. So 2A now becomes 2 because it's half of that, and B is 1. So we have 2 times 1 is 2, 2 times 3.14. Okay, and it should be like 6 something, right? 3.14 times 2, and you get 6.28. And that would be the area of your ellipse. Okay. Moving on. A polygon is any plane figure bounded by straight lines. Examples could include a triangle, rhombus, or trapezoid. All right, all three of these would be examples of that. And then your triangles and your trapezoids and rhombus are all based off of different angles. And you have angles that are all different things. Okay, you have acute angles, and that's less than 90 degrees. All right. You have a right angle, which is exactly 90 degrees. You have obtuse angles, which are between 90 and 180, and you have straight angles, which are exactly 180 and create a straight line. So a triangle is a three-sided polygon, and the sum of the interior angles will always equal 90 or equal 180. So, for example, this is a 90. So if it was equal this way and equal that way, that'd be 45, 45, 90. Or you could have a 30, 60, 90. Or over here, every angle would be the same. Here, one of your angles is going to be obtuse, and then you have two acute angles. Alright, this is all three acute angles. But you add all the angles together, and they will always equal 180. So, the triangle is the simplest and most structurally stable of all the polygons. Alright, and it's why they're used in all types of structure designs, and trusses use triangles as well. Lightweight space frame roof system based on equilateral triangle. Those are just examples that have been used in other ways. Sometimes the terms inscribed and circumscribed are associated with the creation of triangles and other polygons, as well as area calculations. And this is how we can learn those. Okay. Inscribed, the triangle itself is inscribed inside the circle. You kind of got this Iron Man thing going on right here. Okay. And then circumscribed, if we add the Elder Wand for us Harry Potter nerds, okay, you would have the Deathly Hallows. So if you can't remember which one's which based off the geometry, find some sort of nerd thing like that. And that helps me remember it all the time. So, but your circumscribed is the circle is inside the triangle. Inscribed is the triangles inside the circle. Okay. So here your circle's tangent with the surfaces of the triangle. Here the circle runs through the points of the triangle. To find the area of a triangle, the formula is area equals half times the base times the height. Okay. So let's say our example down here. Let's say we had a triangle and it was 3 squares tall and 2 squares long, and here's my triangle. So we have 3 by 2. Alright, so we get area equals half times the base times the height. Base times height would be 6, right? 2 times 3 is 6, then 6 times half ends up being basically 6 divided by 2, but 6 times a half is 3, so it would be 3 inches squared. Okay, 3 inches squared would be that. Let's see here, and that would be a triangle. Back to the PowerPoint. Alright, quadrilaterals are 4-sided polygons, and these can be squares, rhombus, trapezoid, trapeziums. Alright, all those are examples right there. A parallelogram is a 4-sided polygon with both pairs always parallel, hence the parallelogram. Okay, so not all quadrilaterals are parallelograms, but all parallelograms are quadrilaterals. Alright, notice these are surfaces. The one opposite is parallel. So to find the area of a parallelogram, it can be calculated by area equals base times height. So just like a square or a rectangle. Okay. A regular polygon is a polygon with all sides equal and all interior angles equal. So all these equal the same thing. Okay. All your sides equal the same thing, and that'd be a regular polygon. A polygon itself, so a non-regular polygon, would be that the angles could be all different directions, and they could all be different shapes and sizes. Whereas a regular polygon would be like a hexagon, a octagon, things like that. A regular polygon can also be inscribed in a circle, so remember that goes through the points of the object instead of vice versa. And then circumscribed is where the polygon can be placed on the outside of the circle so that all the surfaces line up. Examples of regular multi-solid polygons, once again, pentagons, hexagons, heptagons, octagons. Okay, we just talked about that. So pentagon being like the building, the Pentagon. Okay. And they calculate the area of a multi-sided regular polygon. There's a few different formulas out there, but we have one that we're going to use, and we can calculate as long as we have a side length and we know the number of sides. And that is through this formula here. It is area equals n times s squared divided by 4 tangent times 180 n. Okay, 180 over n. S being the side length, and n being the number of sides. So let's go ahead and work on a problem down here. And I always recommend typing everything out in your calculator. Break it down to its simplest formulas and then start plugging in things just so you don't get caught off guard, you don't put in things wrong to your calculator, and just make sure that you are doing things correctly. So let's assume we have this hexagon that was up there. That's 2, 2, 2, 2, 2. That might not be the exact, but let's assume that it's all 2. Okay, that's 2, 2, 2, 2, 2, 2, 2, 2. We have not a hexagon, but 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon, right? So n is going to equal 8, and the side length is going to equal 2. So then we plug this in. So area equals 8 times 2 squared over 4 tangent 180 over 8. So let's break this down into the individual parts. To start, 2 squared is 4, right? 2 times 2 is 4. And 4 times 8 is what? It is 32. So we have, breaking this down, 32 over 4 tangent 180 over 8. So let's leave this alone in the numerator and let's work on the denominator. 180 divided by 8. 180. And we're going to divide 180 by 8. And you get 22.5. So now we have 4 times the tangent of 22.5. So let's do the tangent of 22.5. Tangent 22.5 tangent, and you get 0.414213, so on, multiplied by 4. $1.65. And we end up with 32 divided by 165. So clear 32 divided by 1.65, and you get 19.39. So the area is 19.39 9 inches squared. Now let's see if we did this right. I'm going to minimize that. We'll open up. And area of regular polygon. So there is probably a formula for that. Calculator. There we go. So we have a 8-sided octagon, right? And the side length was 2, and there was inches, and we can add 6 significant figures. We'll do 4 sig figs. Calculate. Area. There you go. 19. You guys can't see that. Yeah. Area is 19.31 inches squared for that octagon. And so we were pretty dang close with our mathematical formulas. Alright. Sorry, the phone is just moving around. Push this back. And back to our PowerPoint. That was the last slide there. Alright, so those are the formulas. Make sure you use your formula sheets. Talk to your sub, talk to your other students in the class. Back to 5.1. Here's the assignment. I recommend doing that in your notebook. Okay, you got your coordinate grid paper. Using the sketch below, calculate the area of the square, and then pay close attention to the scales. So for example, here it tells you that each grid unit equals 1 square. And then it tells you to kind of work backwards. So question 2 is saying, if this square was 90-inch squares, what would the grid spacing now be? And you would work backwards. So giving your area and knowing it's a square, you can determine the new side lengths. And then 3. I'm trying to look here. Work from there. Trying to see if there's any trick questions here that. That's pretty good. Alright, so make sure you work through those. We basically start you off and then get you through the next part. Question 6, alright, be careful here. You're given a sheet of cardboard that is 8 by 11. How many full circles with a diameter of 3 inches can you cut from the cardboard? Alright, remember circles don't line up nice and pretty. Okay, you're going to have wasted space between each of the circles. And a lot of people forget about that. So you can't just figure out what the area is of the cardboard and then the area of the circle and divide it to see how many can go in, because it won't work out. All right, your circles, you'll have wasted space. So I'm gonna draw an example here. Alright, so you're going to have wasted space between those circles, like here, and there, and there. Circles you might not be able to fit in. So just something to keep in mind when you're doing that problem. Seems to be something that people forget. So be aware of that. And so on. So and then the other thing about 9 is break it into its elements, okay? So you have a triangle, draw an imaginary line here, calculate that area, draw a line up here. So now you have a new triangle, and a square, and then a semicircle. All right. So I usually break this down into 1, 2, 3, 4, 5 different shapes to calculate to bring it back home. So just other things to think about while you're working on this. All right. This one is a little different. The standard stop sign measures 30 inches from flat to flat. There is another formula in your formula sheet that shows you how to do that. All right, so it's a little different than the one that we go off of side length. Yeah, so with that, good luck. If you got any questions, email me. If I have the opportunity to reply, I will. If not, talk to your sub and consult the internet and its infinite wisdom. Make sure you guys are looking at good resources, and have a good day.